Hello there, Mr. Sutton here, bringing you these BC Calculus 517 Extra Practice Number 2 solutions on integration by parts. For this problem, we're trying to integrate this product of an algebraic and a trig function. Since there isn't really a whole lot else we can do here, we try the technique of integration by parts. So let's start with the formula here. That would be uv minus integral of v du, all of that equals integral of u dv. So now let me pick out my u and my dv first. Taking a look at the two things I have here, I've got an algebraic and a trig function. Now, according to my little trick for remembering what to do first, late, L-A-A-T, algebraic is going to come before trig. So I'm going to let my u value be 1/8 x. And my reasoning here is that this is something that's pretty easy to differentiate. It gets nicer when I differentiate it. And now my dv value, this dv right here between these two things, that's going to be sine of 2/3 x, dx. So now u prime, or dv, or du in this case, is going to be 1/8 dx. And v, taking the antiderivative here, that's going to be negative, let's see, we have to divide by the interlinear function here, so negative 3/2 cosine of 2/3 x. All right, using the 7 to put these things together, we go this way, then this way. uv, that's going to be, well, let's see, if I multiply this stuff together, that's going to be negative 3/16 x cosine of 2/3 x. There we go. So that's uv. And now v du, that's going to be this stuff here times 1/8. But we're going to be subtracting that whole integral, so we're actually going to be adding the integral of, let's see here, this is going to be 3/16 cosine of 2/3 x dx. There we go. And now all we have to do is actually take the antiderivative of this expression here, which we can definitely do. So we've got inner function of 2/3 inside this cosine. So again, when we take this antiderivative, I'm going to have to divide by 2/3, multiply by 3/2. Antiderivative of cosine is just sine. So I'm going to have, let's see here, 3/2 times this. That's going to be 9/32. So we have 9/32 sine of 2/3 x plus c. And this is as good as it's going to get. For this antiderivative problem, we have a product, and nothing else, simplifying or anything else, really seems to work on this. So we're going to do our last-ditch effort with integration by parts. So I need to pick out a u and a dv. In my general formula, integral of u dv equals uv minus integral of v du. So you don't get anything for writing this, but I like to have this written down just so I know where I'm putting things. So I need my u and my dv out of this here. So I have an algebraic and an exponential function. Between the two of them, using my acronym of LATE, algebraic takes priority over exponential in terms of picking which one of these you want to be the u value. So I'm going to let u be the algebraic, 9x, and that means dv is going to have to be e to the negative 3x dx. And my reasoning here is that 9x is easier to differentiate. Well, it's not easier. It becomes nicer when you differentiate it, and e to the negative 3x doesn't really become any worse when you integrate it. So that's the reasoning behind these choices. So now doing du, the derivative of 9x, that's going to be 9 dx. And then we've got v, the antiderivative of dv. That's going to be, let's see here, dividing by that inner tail of negative 3, we have negative 1/3 e to the negative 3x. And now putting things back together, first we need uv, so we're going this way, and then we need v du, so we're going this other way, so making a 7 here. Let's do uv first. That's going to be negative 3x e to the negative 3x. And then if we do the other way here, v du, this is going to be, let's see here, negative 1/3 and 9. That's going to be a negative 3. We have an e to the negative 3x. We have a dx. We're already subtracting, so this actually becomes a positive integral of 3e to the negative 3 dx. And all we have to do at this point is take the antiderivative of this integral here. So again, dividing by that inner tail of 1/3, or of 3 rather, negative 3, We're dividing by 3 by negative 3, so that's going to come out to negative e to the negative 3x plus c. And there it is. For this problem, I realized that I've got a product here, and taking a quick look at this, it doesn't look like any kind of simplifying or other tricks are going to help us out here. There's no inner function whose derivative is somewhere else in the problem. So I'm going to resort to integration by parts. So I have integral of u dv equals uv minus integral of v du. I have to pick up my u and my dv to start this off. So I've got an algebraic and a linear, or actually logarithmic function. So using my acronym of LATE, I know that L, logarithmic, takes precedence over algebraic when I'm picking out my u value. So I'm going to let u equal ln of x, and then dv is going to be cube root of x dx, which I'm going to call x to the 1/3 dx. So now taking my derivative of u, that's going to be 1 over x dx. Antiderivative of dv, that bumps up to, let's see, a 4/3 multiplied by 3/4. So 3/4 x to the 4/3. And now multiplying across here to get uv, this is going to be 3/4 ln of x, x to the 4/3. And then going this way diagonally to get my vdu, this is going to be, let's see here, 3/4 times, we can actually combine these x's here. We've got x to the 4/3 minus 1, so that's actually x to the 1/3. So 3/4 x to the 1/3 dx in there. And now I just have to take the derivative of this vdu term. So this exponent bumps up to 4/3 again, and we're multiplying by 3/4 again. So this ends up being 9 over 16 x to the 4/3. We're subtracting that, and we have a plus c to go with all of that. For this problem, I have a product, and there isn't really much I can do in the way of simplifying that's going to make this easier to do. I mean, I could distribute this e to the 1/3 x, but then I still end up with a 5x e to the 1/3 x term, which I don't know what to do with. We can't really use substitution on this one either. So it's going to have to be integration by parts. Integral of u dv equals uv minus integral of v du. And now for my u value, I have a choice between an algebraic and an exponential. And algebraic, according to my acronym of LATE, algebraic comes before exponential when I'm picking u. So I've got a u value of 2 plus 5x. And this will be something that's going to get nicer when I take the derivative. And now I have a dv value of e to the 1/3 x dx. This is something that's at least maybe not getting nicer, but at least it's not getting worse when I take the antiderivative of this. So now taking the derivative of u du, that's going to be 5 dx. And antiderivative of dv, that's going to be, let's see, we have to divide by this inner tail of 1/3. So multiplying by 3, we have 3 e to the 1/3 x. Now I have to plug things in. So we've got a uv and a vdu. Let's do uv first. That's 2 plus 5x in a parentheses times 3 e to the 1/3 x. And honestly, I mean, I'm just going to distribute this. Why not? So that would actually end up being, let's see here, 6 e to the 1/3 x plus 15 x e to the 1/3 x. So just distribute that so I don't have to bother with it later on. And now going this way here, completing the vdu part of this, we're going to end up with, let's see, a 15 e to the 1/3 x dx inside that integral that we're subtracting. All I have to do at this point is actually take this antiderivative. So again, I have to divide by the inner tail of 1/3, so multiply by 3. This then is going to end up being, let's see, minus 45 e to the 1/3 x plus c, with everything else unchanged. And one other thing I could do at the end, I notice I have 2 of these e to the 1/3 x terms, so I could combine those to get a negative 39 e to the 1/3 x to go with everything else, and that would also be an acceptable answer. For this problem, I have this quotient here that's kind of tricky to untangle. I could try substitution, but then I'm going to end up with, I'll end up with an x du up here, but that's not going to cancel out this whole x to the 4th. So that's going to be a little bit of a problem. So let me try something a little bit more creative. I'm going to rewrite this as ln of x times x to the negative 4. Now I have a product, and since I can't do anything else with this product, I'm going to use integration by parts to try to untangle it. So that's going to be integral of u dv equals uv minus integral of v du. So for my u value, I have a choice between a logarithmic and an algebraic function. And using my acronym of LATE to help prioritize, I know that logarithmic is a better choice than algebraic for the u value. Logarithmic, easy to differentiate. The big question here, though, the big consideration is that algebraic at least isn't going to get that much worse when I take the antiderivative. So let's go ahead then and let u equal ln of x. And for my dv in this u dv integral here, I'm going to have that be x to the negative 4th dx. Taking the derivative now of u, du, that's 1 over x dx. And antiderivative of this dv term, well, this exponent bumps up to a negative 3. Dividing by that, we have negative 1/3 x to the negative 3rd. And now going straight across here to get my uv, that's going to be negative 1/3 x to the negative 3rd ln of x, all that stuff. And now I have to get the minus integral v du part, so that's going this way. So I have a minus here and a minus here, so this is actually going to be a plus. And I also notice that this x can be combined with these x's here, so this is going to end up being x to the negative 4th, and we still have that 1/3 hanging around as well. So plus integral 1/3 x to the negative 4th dx. All I have to do at this point is take the antiderivative of 1/3 x to the negative 4th, which I can totally do. This bumps up to an exponent of negative 3. Dividing by that, I'm going to have negative 1/9 x to the negative 3rd plus c, and this one is done. For this no calculator problem, we're trying to take the definite integral from 4 pi to 8 pi of this craziness right here. So the key on this is recognizing that we have a product that we can't really untangle or simplify in any other way. Substitution's definitely not going to work on this one. So what we'll try instead with products that can't be done any other way is integration by parts. So that's going to be integral from a to b of u dv is going to equal uv evaluated from a to b minus integral from a to b of v du. So we don't get anything for writing this down, but I like knowing where I'm putting things, so it helps. So we have to pick a u and a dv to set everything up here. So for my choices for u, I have a choice between this algebraic 12x and this trigonometric cosine function. Using my acronym of LATE to help prioritize, I know that algebraic is a better choice than trigonometric for the u value. So I'm going to let u equal 12x. So this will be something that I can easily take the derivative of, and cosine at the very least is something that won't be horrible to integrate. It's not going to get much worse. So my dv then, I'm going to do cosine of 1/4 x dx for that. And now my du, the derivative of 12x, that's going to be 12 dx. Don't forget the dx in there. Antiderivative of dv, v, that's going to be, let's see here, we have to divide by this inner tail of 1/4. So multiply by 4. So we end up with 4 sine of 1/4 x. And now I have to plug things in. So going straight across for uv, this is 12x times 4 sine of 1/4 x. I can write that as 48x sine of 1/4 x, evaluated from 4 pi to 8 pi there. Goes right into the evaluation box. Now I have to deal with this integral, or at least find out what's in the integral. So going this way now, we've got 4 times 12, which is 48. We still have a sine of 1/4 x dx, so that's all there. Now I have to take the antiderivative of this stuff. So we still have to divide by that inner function, tail, 1/4, divide by 1/4, so multiply by 4. What's 48 times 4? Well, that's going to be, let's see, 4 times 40 would be 160. 4 times 8 is 32. 160 plus 32 is 192. Antiderivative of sine is negative cosine, so this actually becomes positive 192 cosine of 1/4 x, evaluated from 4 pi to 8 pi. And I'm just going to put all of that inside the same evaluation box as this stuff in the beginning, because it has the same limits of integration, 4 pi to 8 pi. So I can put it all together at once. All right, so this is my setup now. This was a no calculator problem, so I still have to keep going here. So I'm going to take all of this stuff with 8 pi plugged in, and I'm going to subtract all of this stuff with 4 pi plugged into these 1, 2, 3 spots. These are all constants, so if I wanted to, I could be done with the problem and just move on. But if you're curious what this simplifies to, maybe just for practice in case it's a multiple choice question, the key is looking at what's going on with these trig functions before you even bother multiplying anything. So for example, this is sine of, well, let's see, 1/4 of 8 pi is 2 pi. What's sine of 2 pi? That's 0. So this whole first term gets zeroed out. Now here we have cosine of 2 pi. Cosine of 2 pi is 1, so we have 1 times 192, which is 192. So this whole first expression, it's just 192. Over here, again, sine of 2 pi is going to be 0, so that first term is gone. Over here, we have, this is actually going to be, I take it back. This was going to be sine of just pi. Still 0, but it's sine of pi, not 2 pi. Over here, now this will be important over here, this is going to be cosine of 1 pi, which is -1. So this is going to be negative 192 right here, except that we were subtracting this whole parentheses full of stuff. So this is minus 192, which is plus 192. And those things are going to add up to 384. Maybe that's why you shouldn't simplify unless you absolutely have to, but we did, so here we are. For this definite integral, I'm dealing with a product of two things that I can't really combine or simplify. Integration by substitution is not going to help us out on this one. The inner function 4x, the derivative of that's not going to give me anything I can cancel out this x with. So instead, I'm going to try integration by parts. So we have integral from a to b of u dv equals uv evaluated from a to b minus integral from a to b of v du. So now I have to pick out my u and my dv values, u and dv, to get this set up here. So for my u value, I've got a choice between this algebraic function x and this exponential function e to the 4x. Using my acronym of LATE to help me sort that out, I know that algebraic comes before e, a comes before e. Algebraic's a better choice than exponential for the u value. So I'm going to let u equal x, and then dv is going to be the e to the 4x dx part of that. Now my reasoning here beyond just my little acronym is I like taking derivatives of algebraics. I mean, derivative of x is going to be pretty easy. And when I take the antiderivative of e to the 4x, which I have to do in a moment, that doesn't really get much worse. So that's also a plus here. So taking du, the derivative of x, that's going to be 1 dx. And v, the antiderivative of this dv here, dividing by my inner derivative of 4, that's going to be 1/4 e to the 4x. Multiplying now to get the uv part of this, I've got 1/4 x e to the 4x, all evaluated from 0 to 3. And we're going to be throwing a few other things in this evaluation box in just a moment, but let's figure out what's going on in this integral. So multiplying this way now, we've got, well, this 1 doesn't really change anything, so we've just got the integral of 1/4 e to the 4x inside there from 0 to 3. And now for this one, antiderivative of 1/4 e to the 4x, we're again dividing by that inner derivative of 4. So this ends up being minus 1/16 e to the 4x. And I can put all of that in this evaluation box with the original term here because we're still going from 0 to 3. Same limits of integration. And at this point, let me just plug 3 into all these x's. We have an x here, here, and here. So all that stuff with 3 plugged in, minus all of this stuff with 0 plugged in. Going from left to right, what are my terms? Well, here I've got, let's see here, 3/4 e to the 12th. And we're going to be subtracting 1/16 e to the 12th power. And then finally over here, well, this 0 is just going to zero out this whole first term. On this next term, this is e to the 0, which is just 1. So we have a minus 1/16, but we're subtracting it, so now it's actually a plus 1/16. By the way, you could have stopped here after you plugged in 3 and 0. We don't have to simplify if it's a free response, But if you're trying to practice for multiple choice, then let's keep going. So if I wanted to combine all these, I guess I could get a common denominator. 16 is probably a good bet on this one. Let me just make this first term 12 over 16 e to the 12th. And then I can put these all under one denominator. So 12 e to the 12th minus 1 e to the 12th plus 1 all over 16. And if I really want to, I can combine those e to the 12ths into an 11 e to the 12th plus 1 over 16. And there's really isn't anything else you can do to make this look any prettier, so I'm going to call this done.